Like, how do you even keep up with all this stuff?
Yeah.
I want to understand what's actually happening, what's real, and what's hype.
For sure.
Without getting bogged down in all the technical details.
Yeah.
So that's what we're going to do today.
That's it.
We're taking a deep dive into a more cautious perspective on these near-term AGI predictions. And we've got a great guide for this.
Right.
Yann LeCun,
Yeah.
the chief AI scientist at Meta.
That's right. One of the leading thinkers in the field.
And
he's got some serious credentials.
oh, yeah.
Not just some random guy with an opinion.
No.
This is someone who is often called one of the godfathers of AI.
Yeah.
A Turing Award winner.
That's like the Nobel Prize for Computer Science.
Exactly.
So when Yann LeCun speaks about AI, people listen.
Right.
What's particularly interesting is, he was a huge advocate for neural networks back when a lot of people in the scientific community had basically given up on them.
Right.
And you know what?
Right.
He turned out to be right.
He did.
So when he expresses skepticism now about AGI arriving so soon, I think it's worth paying attention.
Definitely.
So what we really want to understand today is, why is LeCun saying there's absolutely no way in hell that we're going to see AGI in the next 2 years?
Right.
He actually uses those words, absolutely no way in hell.
Yeah.
Pretty strong language.
Not mincing words.
Yeah, not at all.
And he even calls the idea of a country of geniuses in a data center.
Okay.
Complete BS.
Complete BS.
Yeah.
So where does this country of geniuses idea even come from?
So this actually comes from an essay called Machines of Love and Grace by Dario Amodei, the CEO of Anthropic, which is another, big AI company.
Okay.
And in this essay, Amodei paints a picture of a future where AI becomes way smarter than any human across all fields.
Wow.
Like, imagine an AI that's smarter than all the Nobel Prize winners combined.
That's pretty hard to imagine.
Yeah.
So what would that even look like?
Well, Amodei talks about these systems being able to do human-level tasks, but at incredible speed.
So
they could, solve scientific problems, write amazing literature, compose beautiful music, all that stuff that we consider, the peak of human creativity and intelligence.
Right.
But, much, much faster than any human could.
And what's LeCun's take on this?
Well, LeCun is basically saying that this is not going to happen anytime soon, at least not in the next 2 years.
Right.
He's pushing back against this idea that we're on the verge of this kind of super intelligence.
Interesting. So we've got this range of predictions.
Yeah.
Amodei saying 2026, 2027.
Yeah.
There are even reports that OpenAI is working on what they call PhD-level super agents.
Right.
And then you have Demis Hassabis over at Google DeepMind taking a slightly more cautious approach.
A little bit.
Saying it's a handful of years away.
Yeah.
And then LeCun just flat out says, no way.
No way.
It's a pretty stark contrast.
It is.
So what's LeCun's own timeline then?
Well, even though he's very clear about the next 2 years, he does give his own estimate for when we might see something that at least feels like human-level AI.
Okay, I'm curious.
He says it'll probably take at least 5 or 6 years.
5 or 6 years.
Yeah.
And that's assuming a lot of things go right. Like, we need the right AI architectures. We need to be able to scale these systems effectively.
Right. And of course, we can't have any major unexpected roadblocks.
Which you never know.
Never know.
With research, there's always the unknown unknowns.
Absolutely.
So does he think he's definitely right about this 5 or 6 year timeline?
Well, he's actually very careful to say that he could be wrong.
Okay.
He acknowledges that, predicting the future of AI is a tricky business.
Right.
And he points out that throughout the history of AI research, people have often underestimated how quickly things would progress.
So it's possible that things could move faster than he expects?
It's possible.
But it sounds like he's pretty skeptical of these shorter timelines.
Yeah, he's definitely more on the cautious side.
Especially those coming from people like Sam Altman and Dario Amodei.
Exactly.
So what's the basis for his skepticism?
Okay, so to really get this, you need to understand LeCun's view on the limitations of the current state-of-the-art AI, which is these large language models, or LLMs.
Yeah, LLMs, everybody's talking about them.
That's right.
ChatGPT, Bard, all these things.
All those,
They're really impressive.
They are.
But LeCun is not convinced that they're the path to AGI.
Right, and he uses this really interesting analogy to illustrate this point.
I like analogies.
He compares the amount of data that a 4-year-old child takes in to the massive data sets that are used to train these huge LLMs.
Okay, so how much data are we talking about here?
Well, he says it's roughly the same amount in both cases.
Really?
Around 10 to the power of 14 bytes.
10 to the power of 14 bytes?
Yeah.
That's a lot of bytes.
It is a huge amount of data.
So a 4-year-old child and a massive LLM are both processing similar amounts of data.
Right, but here's the crucial difference.
Okay.
That child's data comes from all these rich sensory experiences.
Yeah.
Everything they see, hear, touch, smell, taste.
Right, the whole world around them.
Exactly. And this happens over about 16,000 hours that they're awake during those first 4 years. Wow.
Now think about LLMs. They're mostly trained on text.
Right, just words.
Yeah, and LeCun actually did the math.
Okay.
He calculated that to read that amount of text.
10 to the power of 14 bytes worth of text.
Yeah.
How long would that take?
It would take a single person almost 500,000 years.
500,000 years.
Yeah.
That's mind-boggling.
It really puts things in perspective.
So what's the takeaway here?
Well, LeCun's argument is that we're never going to get to human-level AI by just training on text.
Just feeding these models more and more text.
Yeah, because they're missing this crucial understanding of the real world.
Right, they don't have that embodied experience.
Exactly. That's what LeCun emphasizes.
It's like they're learning in a vacuum.
In a way.
Yes.
Just from words.
They don't have that grounding that humans and even animals get from actually interacting with their environment.
Makes sense.
So you can keep scaling up these language models, make them bigger and bigger, but LeCun's saying it's not going to bridge that gap to true intelligence.
Because they lack that real-world experience.
Right.
It's interesting because it's not just LeCun who's saying this.
No, it's not.
Meta's own CTO has also said publicly that he wouldn't bet against LeCun's long-term view.
Right.
And that we need to move beyond just scaling these LLM models.
Exactly.
If we want to achieve truly advanced forms of AI.
To get to that next level.
Right.
And this actually connects to a broader idea in AI called Moravec's paradox.
Moravec's paradox.
Yeah, it's this fascinating observation that things that seem easy for humans, like, a cat walking across a cluttered room or a child clearing the table after dinner, those things are actually incredibly difficult for AI.
Really?
Yeah. Well, things that we once thought were uniquely human.
Like what?
Like, understanding language, playing complex games.
Right.
Those have actually turned out to be relatively easier for AI.
That's kind of counterintuitive. The things that we find effortless are really hard for AI.
And the things that we consider, high-level cognitive abilities are kind of easier.
So what does that tell us about AI and intelligence?
Well, it makes you think about what we really mean by intelligence and how our intuition about it might not be the best guide when it comes to building AI.
So if LLMs aren't the answer, what is?
Well, that's the big question.
Yeah. What's LeCun's alternative?
So LeCun is proposing a pretty radical shift in how we think about AI architecture.
Okay, so what does he want us to move away from?
He basically says we need to abandon several key approaches that are very popular in AI research right now.
Like what?
So first he says we should move away from generative models. Then probabilistic models.
So he's got a whole list.
Yeah, he's proposing some pretty fundamental changes.
Instead of those two things, what does he want to use?
Okay, so instead of probabilistic models, he advocates for something called energy-based models.
Energy-based models.
Yeah. Then he says we should move away from contrastive methods and towards regularized methods.
Okay, what about reinforcement learning?
Yeah, he's not a big fan of traditional reinforcement learning either.
So what does he prefer?
He suggests we should focus on model predictive control.
Model predictive control.
Yeah, it's a different approach.
And this is all connected to his belief that LLMs are not the way to go.
Exactly. He actually said, and I quote,
Go ahead.
"If you are interested in human-level AI, just don't work on LLM."
Wow, he's not holding back.
No, he's very clear about his position.
So why is he so against LLMs?
Okay, so his main argument is that LLMs are inherently limited. Because they work by predicting the next token in a sequence.
Token.
Yeah, which could be a word or part of a word based on what came before.
So like predicting the next word in a sentence.
Exactly. And this is what's called autoregressive.
Autoregressive. So they're just kind of going one word at a time.
In a way, yes.
And what's the problem with that?
Well, LeCun says this can lead to problems.
Okay.
Like, generating text that doesn't make sense.
Yeah.
Or isn't factually accurate.
Which we often call hallucinations.
Exactly.
But it sounds like he's got a deeper issue with LLMs.
Yeah, the bigger problem is that he doesn't believe LLMs are capable of true reasoning and planning.
Okay.
The kind that humans and animals do.
Why not?
Because they don't have these internal mental models of the world.
So they're just kind of pattern matching.
In a sense, yeah.
Without really understanding what they're talking about.
Right. They don't have that deeper level of comprehension.
So what's the solution?
Well, this is where LeCun's proposal comes in.
Okay.
Something called JPAD.
JPAD?
Yeah, it stands for Joint Embedding Predictive Architecture.
Joint Embedding Predictive Architecture.
Quite a mouthful.
It is.
But it's a very different approach to AI.
So how is it different?
Well, unlike LLMs, GPay is not a generative model.
Not generative.
No.
So what does that mean?
It means that instead of trying to create or predict the actual raw data.
Like the next word in a sentence or the next pixel in an image?
Exactly.
Okay.
GPay focuses on learning abstract representations of the data.
Abstract representations.
Yeah.
So it's not trying to generate the actual data itself.
Right. It's trying to understand the underlying structure of the information.
Okay. So can you give me an example?
Sure. Let's say you're training a GPay model on video data.
Okay.
Instead of trying to predict the exact sequence of pixels for every frame.
Which would be incredibly complex.
Yeah, practically impossible.
Right.
GPay learns to predict these abstract representations of what's happening in the video.
Okay. I think I've started to get it.
So it's like learning the essence of the video without getting bogged down in all the low-level details.
So instead of predicting pixels, it's predicting these higher-level concepts.
Exactly.
And how does it do that?
Well, GPA uses these things called encoders.
Encoders.
Yeah, which are basically parts of the neural network that learn to filter out the unpredictable details in the data.
So they're kind of like simplifying the information.
In a way, yes.
And focusing on the most important parts.
Right, the parts that are useful for making predictions.
Interesting.
And there are different ways to train these GPA models.
Okay.
He mentions contrastive methods, regularized methods.
And even some techniques called distillation.
Yeah, like iGPA and Dino.
Those are some pretty technical terms.
They are.
But what's the main idea behind these training methods?
The key is that they're designed to prevent a problem called collapse.
Collapse?
Yeah, where the encoder basically learns to ignore the input data.
Okay.
And just produces a meaningless, constant output.
So it's kind of like the model giving up.
Yeah, it's not learning anything useful.
So these techniques prevent that from happening.
Exactly.
How do they do that?
Well, contrastive learning, for example, works by pushing apart the representations of different pieces of data.
Okay.
So the system learns to distinguish between them.
I see.
Regularized methods add constraints to the learning process to prevent the model from becoming too complex and overfitting to the training data.
Makes sense.
And distillation methods involve training a smaller student network to mimic the behavior of a larger, already trained teacher network.
Interesting. So there are a lot of different ways to train these models.
Yeah, and they're all aimed at making sure that the model actually learns something meaningful.
So what are some of the cool things that JPA can do?
Well, one really interesting application is in video understanding.
Okay.
Specifically, its ability to detect impossible events.
Impossible events?
Yeah, like things that would never happen in the real world.
Like what?
Like an object suddenly disappearing.
Okay.
Or teleporting from one place to another.
So how does it know that those things are impossible?
Well, by training on a lot of realistic video data, the GPAM model learns to predict what's likely to happen next.
Right.
In that abstract representation space.
Okay.
So when it sees something that violates the laws of physics, the prediction error of the model becomes very high.
So it's like it's surprised.
In a way, yes.
Because it's seen so much real-world data?
Right. It's learned how things normally behave.
And then when it sees something that doesn't make sense, it flags it as impossible.
Exactly.
So it's kind of like a basic form of common sense.
That's one way to think about it.
And LeCun also talks about GPay being action conditioned.
Yes, that's another key aspect.
What does that mean?
So action conditioned GPA takes the current state of the world and a potential action as input
Okay.
And then it predicts what the resulting state of the world will be.
After that action is taken.
Exactly. But remember, all of this is happening in that abstract representation space.
Right. So it's not predicting the actual pixels or the actual physical state of the world.
No, it's predicting these higher level representations.
Okay, but why is that important?
Well, because this is how the system can start to plan.
Okay.
By being able to predict the outcomes of different actions, it can use optimization techniques.
Like what?
Like something called model predictive control.
Model predictive control.
Which is a well-established concept in engineering to figure out a sequence of actions that will lead to a desired outcome.
So it's kind of like thinking ahead.
Exactly. It's like saying, if I do this, then this will happen, and if I do that, then that will happen.
And then choosing the best sequence of actions to achieve a specific goal.
That's the idea.
And LeCun gave some examples of this.
He did.
Like a robot learning to push a T-shaped object into a slot.
Right.
Or moving blue game pieces to a target arrangement.
Yeah, those are good examples because they help you visualize it.
It makes it more concrete.
Exactly.
So it sounds like LeCun's vision goes beyond just these specific architectures like JEP.
Yeah, he's really talking about a whole new way of thinking about AI.
Okay, so what are some of the broader implications of his ideas?
Well, one thing he emphasizes is that future AI systems will need to have persistent memory. The ability to remember and build upon past experiences.
Right, because that's something that current AI is not very good at.
Exactly.
They kind of have this short-term memory.
Yeah, they can remember things for a while.
Yeah.
But not in the same way that humans do.
So persistent memory is key.
Definitely.
What else?
He also talks about the need for AI systems to be able to reason and plan effectively. And of course, we need to build in robust and controllable safety mechanisms.
That's essential.
Absolutely.
Especially as these systems become more powerful.
Yeah, we don't want AI to become a danger to humanity.
Definitely not.
So safety is paramount.
What about specific applications?
Well, LeCun envisions a future where we have these universal virtual assistants that are powered by this more advanced kind of AI.
More advanced than what we have now with things like Siri and Alexa.
Oh, yeah. Way more advanced.
So how would they be different?
Well, they would be able to understand us much better.
Okay.
They would be able to learn our preferences, anticipate our needs, and help us in all sorts of ways.
So they would be much more like true assistants.
Exactly.
Not just these kind of limited voice interfaces that we have now.
Right.
And how does open source fit into all of this?
Well, LeCun is a big advocate for open source AI.
Okay.
He believes that to prevent this technology from being controlled by just a few companies, we need to make these foundational AI tools and knowledge freely available.
So everyone can benefit.
Exactly.
It's interesting because he also brought up this concern about geopolitical tensions.
Yeah, he worries that some countries might try to restrict access to AI research.
In the name of national security or something like that.
Right.
But LeCun argues that secrecy actually slows down progress.
Exactly.
So what's the alternative?
Right. He believes that open collaboration is the best way to accelerate innovation in AI.
Okay.
He points out that we're already seeing this in the open source world, where smaller teams are making significant breakthroughs.
Can you give me an example?
Yeah, he mentioned DeepSeek, which is a relatively small company that's achieving really impressive results.
So it's a case of David versus Goliath.
In a way, yes.
And LeCun thinks this is the way to go.
He does. He believes that open source will ultimately lead to faster progress and better AI for everyone.
So it sounds like he's not just talking about technical stuff.
No, he's also thinking about the societal implications of AI.
And how to ensure that it benefits all of humanity.
Exactly. He's concerned about issues of fairness and equity. And he believes that open source is the best way to address those concerns.
Okay, so wrapping up.
Yeah.
What are the key takeaways for our listeners?
Well, I think the main point is that LeCun is really challenging the conventional wisdom about AGI.
Right, a lot of people are saying it's just around the corner.
Exactly.
And he's saying, not so fast.
Yeah, he's urging us to be more cautious. And he's pointing out these fundamental limitations of current AI systems.
Especially these large language models.
Right.
He believes that we need a completely different approach if we want to achieve truly human-level AI.
And he's proposing some radical ideas.
Like GPS.
Yeah, and these other techniques that focus on learning abstract representations of the world.
So it's not just about making AI bigger and faster.
No, it's about making it smarter in a fundamentally different way.
So as a listener, you now have a much deeper understanding of the complexities of this debate.
Hopefully.
And you can see that it's not just about predicting when AGI will arrive.
Right.
It's about understanding the different paths that we could take.
And the potential consequences of those choices.
So here's a final thought for you to consider.
Okay.
What would it mean to shift our research efforts away from scaling up generative models and towards developing these world models that LeCun is talking about?
Interesting question.
What kind of future AI applications might each path enable?
Yeah.
Or even prevent?
It's worth thinking about.
It really is.
And if you're interested in learning more, I would definitely recommend checking out LeCun's paper, which is now called Advanced Machine Intelligence.
Advanced Machine Intelligence.
Yeah, and you can also explore the research around joint embedding predictive architectures.
GPA.
Yeah, there's a lot of exciting work happening in this area.
And a lot to think about.
Absolutely.
As we continue to explore this rapidly evolving field.
That's the beauty of it.
It keeps us on our toes.
Always.
What are your thoughts on today's topic? I'd love to hear your opinions in the comments below. Don't forget to like, subscribe, and stay blessed.